did question 1 to 3. So we're going to continue from there. So we're going to do 4, 5, and 6. Hopefully, we'll be able to complete the 4, 5, and 6. So yeah. So for 4, we are told to find the point of intersection for so for question 4, we are told to find point of intersection of 3 planes, x plus 2y minus z equals to 4. Then 2x minus y plus 3z equals to 3. Then 4x plus 3y minus 2z equals to 5. So to be able to find the intersection of this plane, we are going to solve it the same way we solved those questions. So we are going to write this as equation 1, equation 2, and equation 3. So we are going to turn x to the subject of the formula in equation 1. So that will give us x4 minus 2y plus z. So this will now be our equation 4. So we are now going to substitute x, what we have in x in equation 4. We are going to substitute it into equation 2 and then into equation 3. So that will now be 2 into 4 minus 2y plus z minus y plus 3z equals to 3. So, yes. The second small one. Okay, yeah. So that is now going to be 8 minus 4y plus 2z minus y plus 3z equals to 3. Hope I did not make any mistake. Okay. So this will now give us minus 5y plus 5z equals to, if you carry this 8 to the other hand, that will be 3 minus 8. 3 minus 8, which would give us minus 5y plus 5z equals to minus 5. So if you multiply throughout by minus 5 now, by minus 5 or by 5, whichever one we decide to multiply through. So let's multiply through by minus 5. We have y minus z equals to 1. And this will give us y equals to 1 plus z. So this will now be equation 5. So we are now going to plug x also into this, the second one, which will give us 4 into 4 minus 2y plus z plus 3y minus 2z equals to 5. So this will give us 16 minus 8y plus 4z plus 3y minus 2z equals to 5. So this would give us minus 8 plus 3, that would be minus 5y, plus 4z minus 2, that would be plus 2z equals to 5 minus 16, right? Yes, 5 minus 16. So which means we are now going to have trying to confirm. I think I made a mistake somewhere. 16 minus 8 plus 4z plus 3 minus 2y minus 5 plus 2z. Okay. Okay. Yep. So minus 5, this will now be minus 5 plus 2z equals to minus 11, right? So since we already have our y here, we have our y as this here. So we are now going to plug in this y. We are going to plug in. So this is equation, let's find this equation 6 now. So we're now going to plug in y in equation 5 into the y we have here. So that will be minus 5 into 1 plus z plus 2z equals to minus 11. And this will give us minus 5 plus 5z plus 2z equals to minus 11. Now this will give us minus 5 plus, okay, this will give us 7z equals to minus 11 plus 5. Minus 11 plus 5 will be, okay, I think I made a mistake. Yep, this is going to be minus 5 times 1 is minus 5. Minus 5 times plus z is minus 5z. Yes. So this would be minus 3z instead. Yeah, so this one will be minus 11 plus 5. Minus 11 plus 5, that's minus 3z equals to minus 6. So it means our z now would be equals to 2. That is what our z would be. Now that we found our z, we'll plug in z into equation 5, which will now be y equals to 1 plus 2. It means our y equals to 3. Now that we know our y and z, we can now plug it into equation 4 so that we can now know what x is. So that would be, so it means this will now be x equals to 4 minus 2y plus z. So y is 3 and then z is 2. Z is 2. So this will give us x equals to 4 minus 6 plus 2. X would be equals to 4 minus 6 is minus 2, right? Yes, minus 2. Minus 2 plus 2 is 0. So it means our x equals to 0, y equals to 3, and then z equals to 2. Because they want us to find the lines of intersection, so we are now going to write it as 0, 3, 2. And that is going to be our answer. Does anyone have any question? Anyone with question? Did we get this? So I'm guessing we get that. So
Good evening.
yeah,
Please, can you explain over again, please? I didn't
okay.
press
So
yes.
I'm going to explain again. So we are treating 4A. So we are told to find the point of intersection of three planes, and this is the formula. Like this is the formula we are given. So same way we did yesterday, each one will represent an equation. Equation 1, 2, 3. Then we'll make x the subject of the formula in equation 1, which we did. Now we are now going to plug in x into 2 and 3. So we plugged in x into 2, and then we got this. We got equation 5, which we have here, y equals 1 plus z. We plug in x into 3, and then we arrived at this. We got this equation 6. Now that we got this 6, since we already know our y to be equals to 1 plus x, we can use this to be able to get z here. So we plug in the y that we have in 5. We plug it into 6. So that gives us minus 5 into 1 plus z, since that is our y now. So now we are able to get our z, which makes z equals 2. Now that we know our z, we can plug in z into equation 5. That's 1 plus 2. And that gives us 3. Now that we know z and y, we can now plug it into equation 4, since we've made x the subject of the formula. And then we got as x as 0. So this is the line of intersection. Do you understand it now? We
All
get it
right.
now? Yeah.
Understood. Understood.
Okay.
Thanks so much.
So I'm guessing that if you don't get it, you can probably just rewatch and then be able to pick it up again. So yeah, the second question, which is the B part, is that let B be equals to minus 2, 1. So here we go again. We have our okay. Okay. So let B be 2, okay, minus 2, 1, and 0, and then 2, 6, and 2, then 1, 8, and 4. So they want us to find the cofactors of this matrix. So it's going to be like a right. It's going to be a right. So this is the formula for cofactor, like finding the cofactor of this is the formula. So what this whole formula simply interprets as is that we are going to find the cofactor, and how we'll go about that is that we are going to solve for more like I think we did something similar yesterday when we were doing the inverse, when we were doing the adjunct, yes, more like when we were doing the adjunct. So that is what we are going to do. So we'll start with B11, B11. Let's take this as 11. It's supposed to be B11. So B11 will be equals to um, so B11, okay. So this is what B11 would be. So it is going to be 6, 6, 2, 8, 4. And this would give us, this would be equals to 6 times 4 is 24 minus 8 times 2, which is 16. So this is 8. So B11 is 8. Then B12. So for B12 would be this now. Oh, no. Yeah. So B12 will be this now. B12 will be this. So that will be 2, 2, 1, 4. So that would be 2 times 4. 2 times 4 is 8 minus 1 times 2, that's 2, which would be equals to 6. wait. Yep, 2 times 8, yes, 2, which will be equals to 2 times 4, yeah, which will be equals to 6. Then um, B13, B13 would be equals to 2, 6, 1, 8, which is 2 times 8, 16 minus 6. Okay, I've forgotten the um, plus minus this. Sorry, no, I can't use this. Let me just put it here. Plus minus plus minus plus minus plus minus plus. So this would end up as, because this is plus minus, this is plus, this is minus. So this will end up as minus 6. So yeah, this will end up as minus 6. Because I was wondering, yeah. So this is going to be 16 minus 6. That's 10. That's 10. So we move to the next part, which is now B21. B21 now would now be, now we are going to move to the second row. Yeah, the second row, first column now. So remember, this is going to be minus plus minus. Yeah. So this is now going to be, okay, let me do it by the side so that I'll be able to follow the answer. Okay, so B B21. Plug my laptop. 2 minutes, please. Okay, so B21 now would be 1 0 8 4, and that would be 1 times 4. That's 4, because minus 0 times 8 is 0. So this would be minus 4. This would be minus 4. So B22 would be equals to, so B22 would be equals to minus 2 0 1 4. This will be equals to minus 8. Minus 2 times 4 is minus 8. 1 times 0 is 0. So this is plus. So this is just going to be minus 8. So that is B22. B23 will be equals to um, minus 2 1 1 8. So this will now be equals to minus 2 times 8. That's minus 16 minus 1. Minus 1 times minus 1. Yeah, so that's minus 1, which will be equals to minus 17. But remember that this is minus plus minus. So minus plus minus. So minus times minus would cancel the minus here. So this will be 17. Yeah, this will be 17. So now the third part, which will now be B31 now. B31. So B31 now would now be 1 0 6 2. So this one is plus minus plus. So 1 times 2 is 2. This is minus. So this is plus minus plus. So our answer here is 2. B32 will be equals to B32 will be equals to minus 2 0 2 2. This is minus. So minus 2 times 2 is minus 2. I mean minus 4 rather. Minus 2 times 2 is minus 4. This is 0. So this is minus. So minus times the minus 4 would make this to be 4. Make this to be 4. Then B33 B33 would now be equals to okay, will now be equals to minus 2 1 2 6. Okay, that's 2 1 2 6, which will be equals to minus 2 times 6 is minus 12, minus 12 minus 2, which would give us which will now be equals to minus 14. Minus 14. So now that we have everything, we'll now use all of this to now form a matrix. We'll use all of this to form a matrix. So our matrix would now be okay. So our matrix will now be um, 8, 8 minus 6, 8 minus 6, 10, minus 4, minus 8, 17, 2, 4, minus 14. So this is our cofactor. So this is the cofactor of B. This is the cofactor of B. Any question? Do you have any question? So the next one, which is a bit long. It's a bit long. So the next one is it's a 3-in-1 question, question 5. Okay, I think someone is raising. Okay, Uluwatosin, what's the question, please? Uluwatosin, you raised your hand. You can unmute your mic. Okay, I'm guessing that is not a question then. But if you have a question, you can just unmute your mic so that we can get your
Yeah,
question.
sorry, B3.
What do you say?
B23. Is it
B2,
17 or minus 17?
it is 17. Remember this rule, minus plus minus. So this is
Okay.
minus times 4, this is 4, but because it's minus plus minus, the second one, this makes it minus 4. This is minus 8, this is plus, so this is give minus 8. This is minus 17, but because it is minus, so minus 17 times minus. make it plus.
All right, thank you.
Yeah, so make sure you remember that anytime you are doing that so that you don't make a mistake with it. Okay, good. I will not be having issue with representing by matrix. Okay, now question 5. Question 5 is B. So our B equals to this matrix equals to 3, 1, 1, 2, 4, 2, and then 1, 1, 3. So we are told to find three things. We are told to find one, the characteristic polynomial of matrix B. So characteristic polynomial of matrix B, that is what we want to find. And the characteristic polynomial of matrix B is just something like this. It's just something like this. It's something like this. B minus lambda. I said we should represent this with lambda. So when you are writing it, make sure you write lambda in your notes, but I'm representing this with lambda. B minus lambda I equals to 0. B minus lambda I equals to 0. So that is, please give me a few minutes. Let me call you back. I'm in a class. So B minus lambda I equals to 0. So that is, I am in a class. Let me call you back. B minus lambda I equals to 0. I'm sorry. So, so it means we are going to do something like this. We'll have something like, yeah, we'll have something like this. We'll have something like this. 3, this will be something like 3 minus lambda 1, 1, 2, 4 minus lambda 2, then 1, 1, 3 minus lambda. So this is our this is what this is. This is it. So remember, the first thing is we are finding the characteristic polynomial of matrix B, right? So the next thing we now have to do, now is to solve this. So to solve this now, this will be 3 minus lambda into the same thing we did the other time. This and this. Escape. Yes, the same thing we did. Escape. So that's 4 minus lambda 2, 1, 3 minus lambda, then minus 1 into, that's the next one, minus 1 into Okay, minus 1 into 2, 2, 1, 3 minus lambda. Then plus 1 plus 1 into 2, 4 minus lambda, 1, 1. So we are going to multiply this 3 minus lambda into 4 minus lambda, 4 minus lambda dot 3 minus lambda minus 1 times 2, 2. Then minus 1 into 2 into 3 minus lambda minus 2. Okay, 1 times 2, 2 minus 2. Then plus 1 into 2 times 1 is 2 minus 1 times 4 minus lambda, that's 4 minus lambda. So now we are now going to multiply this. So multiplying this, so first of all, we want to multiply this lambda. We have 3 minus lambda into 4 times 3 is 12. That's 12 minus 12 minus 4 times lambda. 4 times lambda is 4 lambda. Then minus 3 lambda, that's 3 times lambda. Then plus lambda square, lambda raised to power 2. So close brackets, close brackets. Okay, lambda square, then minus 2.
Bro,
Hello?
can you hear me?
Yeah, I can
Yes,
hear you.
okay. Um, are we still using the sign notation for the matrix? That is the plus, minus, plus
Yes, we are
for
using it.
the.
Yes. So that
Oh,
is why we have this is plus, this is minus. You see, this one is minus 1, plus minus 1. But for polynomial character, it is only the first one that you are doing. You are not doing for everything. Do you get it?
all right, understood.
Yeah, okay. So then this will now be minus 1 into, this is 2 times 3 is 6. 6 minus 2 lambda minus 2. 6 minus 2 lambda minus 2. I think I can write minus 2 directly. So that's what we have in the second bracket. Then the third bracket is easy. This one is plus 1. Plus 1 into 2. We just want to multiply these two by minus. So this is minus 4 plus lambda. So that is that equation. So we solved all of this. This is still 3 minus lambda into, this is 12 minus 7 lambda plus lambda square minus 2. We can decide to minus from everything we have here. So this is going to be minus 6 plus 2 lambda plus 2. Then plus 2 minus 4 plus lambda, right? But we are still not done. Because we still need to multiply 3 minus lambda with what we have in this bracket. So that would now be 3 times 12 is 36 minus 3 times 7 is 21 lambda. 3 times, so that would be 3 lambda square. 3 lambda square. Then minus 3 times 2 is 6. So that's the first part. We've only done for 3. So now minus lambda, that is minus 12 lambda. Minus lambda times minus 7 lambda would be plus 7 lambda then minus lambda cube. So this is lambda cube, then plus 2 lambda, sorry, plus 2 lambda. Now we now have minus 6 plus 2 lambda plus, we can add this up. This is 2 plus 2 is 4. 2 plus 2 is 4. 4 minus 4, that is 0. So this one's already, they've taken care of themselves. All of these ones, they've taken care of themselves. Then plus lambda. So we contrast all the compelling sides. So we would have minus lambda raised to power 3, right? This is supposed to be 36 minus 21 plus, okay, this is supposed to be plus, yeah. So plus 3 lambda square, lambda square, we've dealt with square. So now let's deal with all the lambda. Minus 21 minus 12, that is, or let's start with minus 12 plus 7, that's minus 5. Yeah, minus 5. Minus 5 plus 2y, that is minus 3, right? Minus 3. So minus 3 plus this one will be 3 plus 3 lambda. So it means all of this, they've cancelled each other out. So we'll be left with just minus 21 lambda. Minus 21 lambda. Remember that we've cleared, so yeah, we now have minus 6 minus 6 minus 6, that is now minus 12. Let me confirm. I think I made a mistake. I made a mistake somewhere. Okay. Permit me to retrace. So please permit me to retrace. Minus 12 for 3 plus y minus 2 minus 6 minus 2, yes, minus 2 plus 2 here. So in multiplying this, 12 minus 4 minus 3, 12 minus 4 minus 3 plus lambda square minus 2. Okay. Okay. I think where I got it wrong would be, let me go back from here. Yeah. 3 lambda into dealing with what we have in this bracket first. Dealing with what we have in this bracket first will be 12 minus 2. This is 10. So 10 minus 7 lambda plus lambda square. Yep. So minus 1 into 6 minus 2 is 4. 4 minus 2 lambda, then plus 1 into minus 2 plus lambda. Yep. Okay. So we will now have 3 times. So let me just directly do the lambda, this one straight up. 3 times. Okay, this will be 3. This will be 30 rather. 30 minus 21 lambda plus 3 lambda square. Yep. So minus 10 lambda y. Yep, minus 10 lambda plus 7 lambda square. Yep. So minus lambda times this, yes, plus 7 lambda square. Then this times this will now be minus lambda cube here. So this will be minus 4 plus 2 lambda minus 2 plus lambda. Okay, so now we have minus lambda cube for the square plus 3 square plus 7 square. So that is plus 10 square plus 10 lambda square. Yeah, I think that's the way the mistake happened. Plus 10 lambda square. So we've eliminated this and this. We've eliminated this. We've eliminated this. We've eliminated this. Okay. Now, for the lambda minus 21y minus 10, that is minus 31, right? Minus 31 plus 3. Minus 31 plus 3, that is minus 31 plus 3 will be minus 28. Yes, minus 28 lambda. So it means we've also eliminated this, eliminated this, and eliminated this and this. Okay. Then we now have 30 minus 4 minus 2. That's minus 4 minus 2 is 6, minus 6. 30 minus 6, that is plus 24. Plus 24 equals to 0, right? So removing the minus because we want the lambda to be positive, like the first value to be positive. So this would be lambda raised to power 3 minus, because we'll divide through by minus. So minus 10 y lambda square plus 28 lambda, then minus 24 equals to 0. So this is just the first question we've answered. So our characteristic polynomial of matrix B would be this. So this is going to be our characteristic polynomial of matrix B. Did we get it up to this level, please? Did we get it to this level? Did we, please? Is there anyone with question? Anybody with question? Okay, I'm guessing we are good here. So the next thing we want to find now is the eigenvalue of matrix B. Now, this is now the long process. To get the eigenvalue of matrix B, we will now have to solve this polynomial. We have to solve this polynomial to be able to get the, we want to get lambda, basically. That is what getting the eigenvalue is about. It is about solving lambda, like getting lambda, like getting all the values of lambda. So this is I've forgotten the word now. This cube. This is cubic equation. Yes, this is a cubic equation. So in order to solve this now, first we want to find the first value for lambda. So we would find value that would make this equals to 0. That is, if we plug the value here, it will turn this to 0. So through trial and error, you can try 1, try minus 1, try 2, try minus 2, just to be able to get the first value of this. But from my hand, so if you from your hand, you can probably just try 1. You can try 1. You can like try 1 minus 1, just to be able to get a result. But for my hand, from the trial and error I did, so I used 2. So 2 is the first value actually, through trial and error. 2 is the first value. So plugging 2 as plugging 2, if you are plugging 2 now, this would mean that this would be 2 raised to power 3 minus 10 into 2 raised to power 2 plus 28 into 2 minus 24. So let's see if this is 0. 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. So this is 8 minus 2 times 2. 2 raised to power 2 is 4. So 4 times 10, that's minus 40. Then plus 28 times 2 is 28 times 2 is 50. 28 times 2, 56. 56 minus 24. So if we do this calculation, 8 minus 40 plus 56 minus 24 will give us 0. So it means that this is going to give us 0, equals to 0. So it means that one of our values of our lambda equals to 2. So now, by getting lambda equals to 2, this makes it easier for us now to solve this. So it means that we will now use this lambda equals to 2 now to solve this cubic equation. We are going to divide. So our division will be something like this. Escape. Yeah. I just want to be able to draw the. Okay. So now our division will now be something like this. Since this is lambda equals to 2, so this is the same as lambda minus 2. Yes, lambda minus 2. So we would have lambda minus 2 here divided by, so we are now going to use this to divide lambda cube 3 minus 10 lambda square, then plus 28 lambda minus 24, right? So in dividing this, we are going to divide we are going to use lambda. So we use lambda to divide. Lambda divided by lambda cube. We are going to have lambda square. So we have lambda square. So when you are doing cubic division, so after you've gotten this, what you will now do is you multiply this. Lambda times lambda square would be lambda cube minus minus 2 times lambda square is going to be 2 lambda square. So we are going to subtract this. So if we subtract this, this will cancel out lambda because this is minus, this is okay, this is minus lambda plus lambda, it cancels it. So minus here, because this is minus, we are using minus 10 square minus 10 lambda square minus 2 lambda. So this will turn to plus because we are minusing minus lambda. So this will be plus. So this would give us minus 8 lambda square. This will give us minus 8 lambda square. Then we'll multiply again. Lambda, we'll divide rather. Lambda divided by this would now give us, lambda divided by this would give us minus 8 lambda. So we do the same thing again. This times this would give us minus 8 lambda, 8 lambda, 8 lambda square, then minus times, okay, at this point, sorry, I forgot it. I forgot a step here. After this, we are going to bring down this 28. We'll bring this 28 down. 28 lambda, yes. So multiplying this is minus lambda square, then minus 2 times minus 8 lambda would give us plus 16 lambda. Okay, so plus 16 lambda. So we'll do the same thing. We'll do the same thing here too. And then this would cancel each other out. Because this is minus minus, yeah, we can use minus, we can also use plus. So we use we can use minus, it's only minus. We subtract this. So if you subtract this, this will be minus minus, this which will turn this to plus. So minus 8 plus this would cancel this out too. We'll cancel this out. So that would now mean we now have 28 minus 16, 28 lambda minus 16. This should give us 12 lambda. 12 lambda will bring minus 24 down, minus 24. So lambda divided by 12 lambda will be plus 12, plus 12. So we'll do the multiplication. This will be 12 lambda minus 24. Yeah, so if we subtract this, this will cancel out the whole question. So this has now given us a quadratic equation to solve. I hope we get it up to this. I hope it's not sounding like jargons. I guess it's because I'm explaining it digitally. That's why it's probably a little bit rough, kind of. Yeah, but so now we have like this quadratic equation. So we will now solve this quadratic equation to be able to get the other lambda value. So what we are solving is y square minus 8y plus 12. So to solve this, we are looking for, that will be 6 and 2. That will be minus 6 and minus 2. Yes. So that will be lambda minus 6 into lambda minus 2 equals to 0. So it means lambda would now be equal to 6 or lambda equals to 2. So it means our eigenvalue is lambda equals to 2, lambda equals to 6, lambda equals to 2. So it means we have two times. Did we get it up to this level? Any question? Any question? Any question? So I'm guessing that there is no question. So we are going to continue. Now we've done I, which is the characteristics polynomial, which led us to this. So this is the characteristics polynomial. We've done II, which is the eigenvalues, which is what we have here, all the eigenvalues. Now the third thing we now want to do is now to get the associated eigenvector. And if you remember, we did something like this yesterday. I'm trying to see, yes. We did something like this yesterday where we solved something like this. So this is the same thing we are going to do for that equation. So now we are now going to do it one by one. Yeah, we are going to do it one by one. So we'll start with when y equals to 2. But since we already have 2, we have lambda rather having like two twos, so we'll just leave it at one. So what we want to do is when lambda equals to two, we'll have something like this: b minus b minus lambda two. I mean b minus two I rather, b minus two I. So that's what we are going to have. Okay, someone asked question. What's your question?
Sorry, your camera, the screen is not showing.
Okay.
All
Is
right.
that only peculiar to her? Is any other person not?
It's on now.
Okay.
I can see you now.
Okay. All right. So yeah. So we are now going to do b equals to, b minus 2i. That is when, so this is what we are going to do. So remember our b. This is our b. So we are coming back to this. Control C. Control C.
Okay.
Then please let's mute our mic, please. Thank you. Okay, yeah. So minus so this is our b. I just want us to remember our b. So what this would now mean now would be that we would subtract. Remember that, so this would be minus 2i would be 2i will be 2 minus lambda. Please let's meet our mic, please. 2 minus lambda 0 0. Please let's meet our mic. Let's meet our mic, please. 2 minus 2 minus lambda 0. Ma, please mute your mic. Please mute your mic. Thank you. Thought. Okay. Yes. So this is what B is now. So this is oh, we don't need this lambda. I've forgotten that. The lambda is now the 2. Forgotten. Sorry. Yeah. So this is what's 2i. This is 2i. All right. So this is now what we are subtracting. We are subtracting this from this when y equals to 2. So this would give us 3 minus 2. 3 minus 2 is 1. So this will give us 1, 1, 1. 2, 4 minus 2. 4 minus 2 is 2. 2, 2. And then 1, 1. 3 minus 2 is 1, 1. So this is going to give us this matrix. So this is going to give us this matrix, and then we have yeah. So this is going to give us this matrix. And then we are now going to have V1, V2, V3 beside it. V1, just like we did yesterday. V2, V3 will be equal to 0 actually. So we will now turn this into a formula which would be V1, this like multiplying what we have here by this will be V1 plus V2 plus V3 equals to 0. Then the other one will be 2V1 rather, 2V1 plus 2V2 plus 2V3 equals to 0. So from this equation, our V1 will be equals to minus V2 minus V3. That's what our V1 would be. So we are going to set arbitrary number. You would write it, like by the time you want to do it, you are going to write it that you are setting arbitrary number to this particular. So let's set our V2. Let's set V2 to be equals to 1 and V3 to be equal to 0. So this would now mean that our V1 would be equals to minus 1. That's what our V1 would be. So our V1 would be minus 1, our V2 would be 1, and then our V3 would be equals to 0. So that's for the first one. Then we do the same thing too for when what's it called now? We do the same thing for when our lambda is, this is for when lambda is 2. So we do the same thing for when lambda is 6. When lambda is 6, yes. For when lambda is 6, we do the same thing, the same process. So so for when lambda is 6, so let me just copy the same thing that I have here. Let me copy the same thing that I have here. Okay, so for when lambda equals to 6, so it means this would be 6, and then this would be 6, right? So if you subtract this minus 3 minus 6, 3 minus 6 would give us minus 3. So this would be minus 3. 4 minus 6 would be minus 2. And then the last one is 3 minus 6. 3 minus 6 is also minus 3. So we have minus 3, 1, 1, 2 minus 2, 2, 1, 1, 3. Yep. So we have this. Then we'll solve again. We'll have minus 3 V1 plus V2 plus V3. Then the second equation will be 2V1 minus 2V2 plus 2V3. Then the third equation is V1 plus V2 minus 3V3. Everything equals to 0. Equals to 0. Equals to 0. Equals to 0. So now that we have done this, yep. So V1, our V1 here equals to minus V2 plus, is 3v3, more like 3v3 minus v2, or minus v2 plus 3v3. So, so we have our v1 here. We have our v1 here. So let's plug this v1. Let's plug it into. Let's plug this v1 that we have. Let's plug it into any of the equation. Let's plug it into equation 1 and equation 2 rather. So the v1 we have here, we'll plug it into equation 1 and equation 2. The reason we could not do the same here is because we only have we only have 2 equations. So we will not be able to like get a solution if we did that. I mean, these values are the same because by the time you divide 2 by 2, you have the same formula. That's why we could not do what we are doing here. So our v1 is 3v3 minus v2, right? So plugging it into equation 1, that would be minus 3 into 3v3 minus v2 plus v2 plus v3 equals to 0. So that will be minus 9v3 plus 3v2 plus v2 plus v3 equals to 0. This should be minus 9 plus, that is minus 8 v3 plus 4 plus 4v2 equal to 0. This should mean that if we take this to the other side, that's 4v2 equals to 8v3. Divide through v2, it means our v2 equals to our v2 equals to
2v3.
2v3, yes, thank you. 2v3. So now we know v1, we know v2. We can plug it into, let's plug it into equation 3. Let's plug it into equation 3. Yeah, let's plug it into equation 3. So if we plug it into equation 3, that would be v1. Our v1 is 3v3 minus v2. Our v2 is 2v3, so that's plus 2v3, then minus 3v3 equals to 0, right? So this would mean that 3v3 minus 3v3 cancels each other. So we have a minus, oh, what? No. Okay, yeah, it cancels each other. Minus v2 plus 2v3 equals to 0. I think we are still arriving at the same thing. V2 equals to 2v3. We are arriving at the same thing.
V2 should be 2v3.
What do you say? Yes, I know. Yes,
2v3.
2v3. Yes, we are arriving at what we already have here. So let me see if we plug it into, this is v1 minus 2v2 plus, no, v1 minus v2 plus v3 equals 0. v1, is it not the same thing? Okay, this is different. I think let me see. v1 is 3v3 minus v2 minus 2v3 plus v3. Okay, let me see if this changes anything. No, it doesn't. It's still, yeah, we still end up at the same, yeah. So we still have the same value. V2 is 2v3. So it means we are going to give our v3 a value. So let v3 be 1. Let v3 equals to 1. Then it means our v2 would be equals to 2 into 1. So it means our v2 would be equals to 2. our V2 will be equals to 2. So if our V2 is equals to 2, our V1 now would now be equals to V1 equals to 3V3. V3 is 1, that is 3 minus V2 is 2, 3 minus 2, which is equals to 1. So it means our V1 equals to 1. So it means V1 equals to 1, V2 equals to 2, and then V3 equals to 1. V3 equals to 1. So we've done for the first one, lambda 2, we've done for 6. We are also going to do for lambda 6. I mean, we've done for lambda 6. We are also going to do for lambda 2 again. But when we are doing for lambda 2 the second time, the value we are going to be using for, what's it called now? Earlier on, we let V2 to be, what did you make V2 here? Okay, let's set V2 to be 1 and 0. So in this case, you can now, I think you change, yes, you can swap, make the other one 0, like V2 0, and then the other one 1, like for the second one. For the second V2, I mean for the second lambda 2, So the second lambda 2 would be set V2 equals 0, and then set V3 equals 1. So that would now mean that our V1 would be equals to, that's for the second one. It means our V1 would be minus 1, minus 0. So our V1 is minus 1 in this case, but our V2 equals to 1, and then our V3 equals to 0. So that is this is when lambda equals to lambda 2 for the first one, we have V1 equals to minus 1, basically this. When lambda equals to 6, we have this. Then when lambda equals to 2, the second 2, we have this, but in this case our 1 is minus 1. No, our 1 is minus, which one did I copy first? I don't know. Minus 1, V2 0, yes, okay, and then V3 1. Yeah, so for one of the V2 you have this, for the second V2 you have this. Yep. So that's like the answer. I think you are now meant to now do it in minus 1, 1, 0, 1, 2, 1, then minus 1, 0, 1. Yep. So this is the eigenvector. Yeah, this is the eigenvector for question 5. Yeah, took us a lot for question 5. So we are moving to question 6. 6a is a definition. We are just to define the orthogonality of a matrix. I think you can probably search that out to get like a result. Sorry, okay. So for the second one is for this matrix, this to the side. So this is also going to be another long process because it's a 3 by 3 matrix. Yeah. For this matrix, matrix A, where is my matrix? Okay. So for matrix A equals to 1, 0, 2, 0, 2, 1, then 2, 0, 3. So first, they want us to verify the Cayley-Hamilton's theorem, and then using that, we are now going to find the inverse of this. Okay. So to do that, what we are going to do is remember that for Cayley-Hamilton, we are to verify that this whole formula, this whole thing, by the time we solve it out, is going to turn to zero, like a 0 by 0 matrix. It's going to turn to 0, 0 matrix. So for Cayley-Hamilton, that would be A minus alpha I equals to 0. So that is what we want to verify. I want to verify that this will turn equals to, this will be equals to 0. So this would mean that our equation would be, so I'm just going to plug it straight up in. Actually, again. So plugging it straight up, this would be 1 minus lambda 0, 2, 0, 2 minus lambda 1, 2, 0, 3 minus lambda. So this is what we want to solve. So 1 minus lambda into, so we have 2 lambda 1, 0, 3 minus lambda. Okay. This is minus 0. For this one, we are not going to calculate this because this is already 0. So it's going to nullify everything we already have outside of it. Then this will now be plus 2 into 0, 2 minus lambda, 2 and 0. So this will give us 1 minus lambda into 2 minus lambda, 3 minus lambda. Yes, because the other one will be 0 times 1, which is already 0, which is going to be 0. Yeah, plus 2 into 0 times, this is 0, then minus, this is going to be minus into 2 times 2, here is 4, minus 2 lambda. Yep. So this would be 1 minus lambda into this is 6 minus 2 lambda minus 3 lambda plus lambda square plus 2 into minus 4 plus 2 lambda. Yep. So 1 minus lambda into minus 5 lambda plus lambda square minus 8 plus 4 lambda. Yep. Equals to 0. Then let me continue it here so that it's not going to disturb this. Then that would be, so multiply with 1 minus lambda through the brackets. That is 6. That is all of this. Yep. Minus 6y, 6 lambda plus 5 lambda square. The reason it's plus is because minus lambda times minus 5 lambda, then minus lambda cube minus y times y square, yeah. So minus 8 plus 4 lambda equals to 0. So at the end of the day, we have minus y lambda cube. Then this plus this would be plus 6 lambda square plus 6 lambda square. Then minus 5 minus 6, that's minus 11. Minus 11 plus 4, that is minus 7. Yes, minus 7 lambda. Then 6 minus 8, that is minus 2. Minus 2 equals to 0. So this would be lambda cube minus 6 lambda cube, 6 lambda square plus 7 lambda plus 2 equals to 0. Minus 6, okay, plus 7. Yeah. I hope you understand how we got this. So now that we've gotten this will now mean the same thing as a raised to power 3 minus 6a raised to power 2 plus 7a plus 2i equals to 0. So it means that you now take your a, you multiply it through, you take this matrix, this. Okay. Okay, this by this by this, that's a cube, then minus 6a square, then plus 7a plus 7a. All of this is supposed to be on a straight line, but I'm just trying to preserve the the lines, then minus, plus 2, plus 2, plus 2. Okay, so let me just copy the value, what we have in A now. So, yeah. Um, plus 2, 2 here would be, so what 2 here would be will now be 2, 2 here would be 2, 0, 0, 0, 2, 0, 0, 0, 2. So this is what you are going to do. You are going to multiply this matrix by this matrix. The answer you get, you multiply it by this matrix, right? Then you multiply this by this matrix, then you now multiply it by minus 6. Then you now multiply 7 by this, then plus this. So when you are now done, you now add everything together. At the end of the day, it is going to be 0. At the end of the day, it's going to be 0. I've actually done it written down, but just to save time, I think I want us to, you can probably just take it up and do it bit by bit yourself. So this is going to be 0, and that would be, so with that, you now say that you've been able to verify Cagliari-Amint's theorem since what's it called now? What do they call it now? Since the this since this matrix, like when you get the answer for this, it is equals to 0. Since it is 0, so you now say that it fulfills, it verifies that it fulfills Cagliari-Amint's theorem. Please, did we get that? Did we get that? Did we get how I explained it?
Yes, thank you.
Okay. Okay. Okay, someone is asking question. What's your question? Your question.
Oh, sorry, I raised my hand by accident. Sorry.
Oh, okay, okay. No problem. So, now the next part is now to find the inverse. So we are just going to use Cagliari-Amint's theorem to just find the inverse. I mean, to find the inverse, yes. So we already have this. Copy this. So we already have this. Remember that the inverse is A inverse is A inverse, like A raised to power minus 1, equals to 1 over 1 over 1 over A. I mean 1 over determinant of A. 1 over the determinant of A. 1 over determinant of A equals to, I mean 1 over determinant of A adjunct of A, adjunct of A. Yes. So this is A inverse. I mean, the adjunct of A. So this is the inverse. Now using Caliabin's theorem. So first we need to find the determinant of A. So finding the determinant of A is doing this like I think we did we making 1 then multiplying this by this. So that would be um, equals to 1. 2 times 3 is 6. Yes, for the minus it cancels out because this is starting with 0. 0 will cancel it out. Then plus this is 0 minus 2 times 2, which is minus 4. Minus 4 minus 4. Minus 4, that is plus 4, right? No, that is my 2 times 2 coming. I get okay here. Sorry, which would be plus 2 into yeah, this 2 outside. This is 0 minus 2 minus 2. Sure. Minus 2 times 2 is minus 4. Yeah. Then minus 4. That is plus 4. That is 4. Got it? Am I getting something wrong?
This is 2, no minus 2.
It is 2. This is 2. I'm doing, this is cancelled out. 0, 0. 2 times 2.
Yeah, okay.
Yeah, okay. This is not minus 2. This is 2. Yeah, so this would be
Yes.
minus 4. Yeah. 2 times 2 is 4. Minus 4. Yep. So that would be equals to 6 minus 8, which would be equals to minus 2, right? So now we are now going to plug in. So we have 1 over, I'm calling, sorry, trying to see how this works. Right. Okay. Extrapolating A from here, we would have A into A square minus 6A, right, plus 7, then plus 2y equal to 0. The 7 equals to 0. So this would be A into A square minus 6A plus 7 equals to, taking this to the other side, equals to minus 2i, right? So A inverse would now be equals to minus 1 over 2, minus 1 over 2, minus 1 over 2, minus 1 over 2 into A square, no, Um, I'm coming. Trying to understand how I got this.
Are we not going to look for the cofactor of A?
Yeah, we can do.
The
We can do using the cofactor, like following the. I don't want to follow the long process. There's actually a way of getting the answer using Kaliamintis theorem directly, like plugging in the answer using Kaliamintis theorem. That does not need going through the whole cofactor thing. That is what I'm trying to to use here, but I think I've forgotten. But it's going to be this a square minus 6a plus 7. So 7 here will now be 7i. Yep. So yep, this is something you are going to have. Then what you now need to do will now be to plug in all of this the same way we did this plugin will now be to plug in all of this into this, and then we would have the answer. We'll have the answer. We'll have the inverse, but you can also follow the inverse way. Let me see. I think we did that. We did an inverse yesterday. We did an inverse yesterday. Now
Yes, we did it.
I'm trying
I
to
think
see that.
question 3A or so.
Question 3 is question 3B. Yes. Question 3B. So that's the final thing we did yesterday. Let me see. Yes, this. Yes, you can find the inverse the way we did this. The way we did this, after getting the adjoints, then you now find the cofactor of each one. Yes, finding the cofactor of each one, you get this. Then you now reverse, you turn the, what's it called now? You turn
You do the
the,
trans
yeah,
the
the
rows to
inverse of this. Yes, the inverse of this. But if you do these two, if you do these two, you would get like the same, you get the same answer. So the answer you are supposed to get would be minus 1 over 2, minus 1 over 2 into minus 1 over 2 into 6, 0, minus 4, 2, minus 1, minus 1, minus 4, 0, and 2. And this is the same answer if you plug in A, like if you use this matrix. If you plug in A times A minus 6A, then plus 700,070,007, and you subtract it, it's going to be the same answer. So you can probably just try out the two and let me know what you have. But this is the inverse. This is the inverse of it. Do you have any question? So you can now decide to go ahead and probably divide by 2. That would be, yes, that would be multiplying by 2. Dividing by 2 throughout, like dividing the box. Like you can go ahead and divide this box by half throughout. So this would be minus 3, this would be 0, this would be 2, this would be minus 1, this would be half 1 over 2. So it means this minus 2 would not be outside again. Yeah, you can go ahead and do that. Do you have any question? Did we get this explanation that I did? Please, did we get the explanation that I did, please?
Yes.
Okay, thank you. So, I'm hoping that
But
doesn't
please,
it
I wish you explain
using
this one you were talking about, the
yeah,
Kale Hamilton.
yeah, using this theorem. So this is going to be like this is going to be the final formula. This is going to be the final formula. Then you now plug in the same way we did this one. You know, when we are solving for this, we did a cube this times this times this. That is, you would multiply each of these matrix. You multiply this matrix by this. Okay, let's try to do it. Let's just try to do it. So let's multiply this matrix by this matrix now. The first one. That will be 1 times, okay, 1 times 1. 1 times 1 is 1 plus 0. 2 times 2 is 4. 4. Then 1 times 0, 0. 0 times 0 times, sorry, 0 times 2, 0. Then 2 times 0, 2 times 0, 0. So the middle one will be 0. The third one, this multiplied by this, 1 times 2, 2. 0 times 1, 0. Then 2 times 3, 6. Yes. Then 1 times, so the middle one, 0 times 1, 0. 2 times 0, 0. 1 times 2. So this will be 2. 0 times 0, 0. 2 times 2, 4. 1 times 0, 0. Then 0 times 2, 0. 2 times 1, 2. Plus 1 times 3, 3. 2 times 1, 2. Okay, 2 times 1, 2. 0 times 0, 0. 3 times 2, 6. Then 2 times 0, 0. 0 times 3, 0. 3 times, this is 0. 2 times 2, 4. Plus 0 times, this is 0. 3 times 3, 9. So this will now give us 5, 0, 8. 2, 4, 5, 8, 0, 13. 8, 0, 13. Yeah. So that's a square. So to get minus 6a would be 6 times this, which is 6. We'll multiply 6 through all of this. That's 6, 0, 12, 0, 12, 6, 12, 0. 6 times 3 is 18. Then plus 7, that will be 7, 0, 0, 0, 7, 0, 0, 0, 7. So this minus this plus this. Yeah, so 5 minus 6. 5 minus 6 is minus 1, right? Minus 1 plus 7. Minus 1 plus 7 will be 6. 0 minus 0 minus 0, 0. 8 minus 12 is minus 4, right? Yeah, minus 4. 8 minus 4 is minus 4. The other one is 0, so we don't need that. 2 minus 0 is 0, 0, so we have 2. 4 minus 12 is minus 8. Minus 8 plus 7, that is minus 1. Then 5 minus 6 is minus 1. Then 8 minus 12 is minus 4. 0, 0. 13 minus 18 is minus 5. Minus 5 plus 7 is minus 2, right? I mean, minus 5 plus 7 is 2. So that is how I arrived at this. And we already have the determinant. Yep. So that is how I arrived at this 60 minus 4, 2 minus 1, 4, 0, 0. So it's something similar you do for this. So after you've gotten the square which is where's the square now? Where's the square of A? Okay, this is the square of A. After you've gotten the square of A, you now multiply it again by this in order to be able to get the cube of to be able to get this A3 that we have here for this particular one, right? So did you understand it now?
Yeah, thank you very much.
Yeah, so you can try the cofactor format just to be able to show that you arrived at this this answer too. Do you have any question? So I'm sure I think we've practiced all the past question, and I think it's from the past question that the assignments we are told to do. Toby, I think we have to submit that assignment written, right? We have to write and submit, right?
I guess so, yes.
Yeah, so I think we've
I'll
also
confirm, but yes, you should write.
So I think we've also done all of the assignments. So I am guessing, since this is the assignment, I don't know if it will come out in test. So I'm guessing probably the questions that will probably come out in test might be something around this first one or something. But just make sure you repractice every of these questions again, just to be sure, because if sometimes you think you know it and then there will be just slight errors or slight mistake. And please, when you are writing, make sure that you reconfirm what you just written so that you don't write -7 when you are supposed to write 7. And then by the time you do the final calculation, you are not getting the right answer. So yeah, so I'm going to upload this evening. I'll try to upload this evening to as part 2 so that we can rewatch. I'm not sure we have any question. I'm not sure we have